Okay, daemon management. So this is going to be a little bit lengthy because we're going to have to talk about the history of Unix. So in the 70s, when they created Unix, they had different types of uses depending on the system that it was going to go into and who was going to be using it. So before, we had big mainframes, and it could support multiple users, right? So when they started the system up, they wanted to make sure that they were able to support anything that all users wanted to do at the same time. So what they did was they specified different, they're called run levels, and it's basically a bunch of scripts that you run to initialize applications depending on what you're trying to do. So if you look at the notes here, run levels describe the state of the system defined by the processes each runs. So what that means, if you have a single user, obviously one person can log in. Multi-user, a lot of people can log in locally if they're on a terminal that's actually physically connected to the system. With networking, same thing, but you can actually log in via the network. So when you telnet, back then it was telnet, now SSH into the system. These vary depending on the distribution. So I don't want to get you hung up on one is this, two is that. Just understand that each one of those run levels will give a different type of capability to the system. So the init scripts or initialization scripts are a collection of programs or scripts that the init daemon runs. Init is called by the kernel, and it's the first process that the system runs. Basically, as soon as you boot the computer, whether it's Windows, Linux, Mac OS, it doesn't matter what it is, the kernel is gonna, once it gets loaded into memory, the kernel is gonna say, hey, I need something to run everything else that needs to happen on the system. So in Windows, you actually see a init or system. It's the first process that runs. In Unix-based systems, it's init. Now, init is very archaic. It's pretty old. Again, it's from the 60s actually. And the way init works, it just starts processes that you define in those specific folders. So for each run level, there's a folder that has a bunch of scripts. It's not efficient. So it's basically going to a buffet line and only one person goes and eats. You have all the food out there that's going to go to waste if only one person eats. The other way was, okay, we have one buffet line, everybody's going to go eat at the same time, you're going to run out of food eventually real quick. So, true. Very true. So taking that analogy, they came out with something called Upstart, and there's Systemd, Upstart, there's one more that I think Mac OS uses, but it's basically the same thing. It's just it's event-based. So instead of going back to the restaurant analogy, instead of having all the food out for everybody to come eat at once, they just put the food out as people come in. So you say, I want to eat this, and they give you exactly what you want. So it's all event-based. In computer terms, basically, when the system comes up, it says, okay, you want to use the wireless, but for you to use the wireless, you got to start the network, and you got to bring up the network interface first. So it knows to do those three things at the same time while everything else is starting, because you can't connect to the wireless network unless you have a wireless card that's already available, which in turn the driver has to be loaded into memory for it to be available. So those Upstart's going to take care of that that event, and everything else will continue to run also while without having to wait for those things to happen. So they still use the init scripts or System 5, which is the original spec for Unix back in the 70s. If you go into the directories, you're going to see a bunch of scripts that start with a capital S and a capital K. So when the system's initializing, it'll go run level 1, okay, I'm going to run all these scripts, then I'm going to go run level 2, run these scripts, run level 3, run these scripts, so on and so forth. Unless you specify every single time this is going to be the default, I want to run, let's say, run level 3. You have to specify that. And if you specify that, it'll only look in run level 3. So when you reboot or you're powering off the system, it goes back into the same folder and it's going to look at the scripts with a capital K. So K is for kill, S is for start. So it's going to do the reverse. Each one of those scripts is numbered. So there's a order of precedence depending on the number that you give it to the script. So as it comes up, it's going to start with S0, then S1, S2, S3, so on and so forth. The kill is going to do the reverse. And it's going to stop or kill or stop processes on the way out. Now, if you want to secure those, if you want to prevent one of those applications or services from starting or stopping, whichever, all you have to do is change the name of it. As long as it doesn't have a capital S or a capital K, if it doesn't have it, it won't run. So if you want to secure a service, let's say it's S53 HTTPD, which will be the Apache web server. If you want to prevent it from starting, just change the capital S to a lowercase s, and you're good to go. It's not going to start unless you actually start it up, change it back up. Now granted, that's only booting up and powering off where those scripts apply. You can always go in the command line and type Apache or HTTPD and run it, and it'll work that way too. So you can also type service, then the command name or the application name. You can start, stop, restart. Those are all based on the script. So whatever the programmer wrote into the script is what's going to apply. There are some that actually do have a restart, so it'll stop it and start it for you. Some of those don't have it, so you have to manually start or stop it and then start. If you type the command service -- status tag all, it'll list out all the services that you can control by the service command. Now, on the newer versions of Linux, now they're using, in this case Ubuntu, they're using Upstart because the init scripts are old. But Upstart is backwards compatible, if you will, with the init scripts. So you can still type service, you can still do the init scripts and change the capital S to lowercase. That's how you control them. If they're actually using pure Upstart, you can just type start command name, stop command name, and it'll work. It's the same thing as service.
With that's as the operating system's running. What if you reboot it, just restart again? How do you prevent it? I think my thing is always, how do you prevent it from starting?
So if it's on the init scripts, just change the
run level.
Well, right. You have to go to the specific directory and change it. That's one way. There's another way. I think it's on the other. Might be on the other one. So there's a command that you can run. That what it does is it removes the links to the run levels, so it'll prevent it from starting. But it won't delete the scripts. I'll get that for you. Yeah. I'm pretty sure I have it on the notes. Could be this one. No. I was pretty sure I had it on the notes. Or it could be on the process management part on the security side. So, but we'll definitely go back to that. Okay, outstanding. Okay, let's get this started. Okay, let's get this started. That way we can get out of here quick. All right, we have probably about an hour left. Just gonna fly right through this. So, security in Linux, right? We're gonna talk about the user, the Etsy password file and the Etsy shadow file. So, this is where all your access control and all your security, this is the main point right here. This is where it starts. So the Etsy password file, it contains basically all the user accounts and some information about it. So I have an example here, one of the lines, one of the entry lines in the on the password file, and all the different blocks you can see, they're limited by a colon. So you got Joe, the username, then you have a X. That's just denoting that it has a encrypted password, or actually it's a hash of the password. Then you have your user ID. In this case, 1004. 1001, it's the group ID. Now, I have a comment on the bottom. It says that only root has the user ID of 0. So when you guys are working on your images and you actually open up the password file, make sure that only root has the user ID of 0. If there's somebody else, another account, it doesn't matter what it says, another account that has a user ID of 0, you might want to change that, and you want to take note of who that account is, because that's something malicious, somebody that's trying to impersonate root. So back to the example, it says Linux user. That's just a comment that you can put in when you're creating the account. There's different ways you can create it. You can do a command line like we talked about earlier. You can do it via the GUI. I'm going to show you guys here in a second. Then home/Joe, that's the user's home directory. And bin bash is the login shell. The users not necessarily need to have a login shell. There's actually one called no login. So if you try to use that account, it's just gonna log you off, basically. It's not gonna let you log in as that account. There are other entries in the password file that correspond to an application. And like I said before, only root has the user ID of 0. So the password file basically is the corresponding, it's matching the shadow file. It also contains user account information, but it's just a little bit different. Each entry in the user password file has to have a corresponding one in the user shadow. So again, same guy, Joe, the username. And you see that long cryptic looking string there, starting with the $. That's a hash. Do you guys know what a hash is? Like MD5, SHA-1 to 56, pick a number. You guys know what that is? Hashing algorithms.
We've used it, yeah.
You've used it. Okay. So this is something good to note, that because Linux is based on open source applications, the code is out there for anybody to use and reuse and do whatever they want with it. So you can get the same program and modify it in a way that allows you to do things that the original person who put out the code not intended it to. So you could do bad things with it, essentially. So when you download stuff from the distribution sites, most of the time they're going to have the file and associated hash to it. Basically, the hash is kind of like a fingerprint. It proves that that file is the file that they're saying it is. Same principle here. It's just the hash of the password. a hash is a one-way mathematical function that you can't reverse it. So basically, you open up a can of spam, you put it through a filter, and here comes out this craziness, right? Every single time that you get some spam and you put it through that filter, it's going to come out looking the same. If you get a steak and you put it through the same thing, it's not going to look or be the same as a spam. But you can't, once you put it through that, you can't run it back and make, steak again. It's not going to happen. So this hash, excuse me, there's really don't want to bore you with the other details of the hash, but there's different ways of hashing using different mechanisms to hash a password. You can use MD5, you can use SHA-1, you can use other encryptions like AES, Blowfish. There's multiple ones. Another thing that they do for security in Linux is that they throw a salt. It's basically a random number that they use in combination of the password to come up with that hash. Okay, so every time you type password on the images, it'll come out to the same hash every single time. If you change one character, now it's not the same, so it'll give you a completely different hash. So, okay. So, a couple of the security things that get implemented here, they could be blank. It could be just a bunch of colons. They don't need to contain anything. But if you actually implement it, you need to have a value in there. So, our example 15627 is a last password change. It's the last day that you change the password, and it's the number of days since 1970, the January 1st, 1970. All time in Unix starts at January 1st, 1970, and Windows it starts in 1900. So, little known fact, were you guys around for Y2K, most of you? Yeah, so if you're old enough, you remember Y2K. So basically the problem was that dates only used 2 digits. So 1999, it was 99, so 2000, it was supposed to roll to 1900. Well, the way Windows and Unix implement their systems, Windows starting from 1900, the Y2K thing is going to happen again twice. 1927, I think it is, and in Linux in like 1936. But, oh, I'm sorry, 2036. So having said that, there's a maximum amount of days that you can have in there. You could put 999999 and you might break the system. Minimum password age is the minimum amount of days until you can change the password. So if you have a user log into a system, or they just recently changed their password and they forgot the new password, you give them a new one, they just can't go ahead and change it back to an old one. They have to wait a certain amount of days. In this example, it's 15. Windows, they do the same thing. When you're part of a domain, they have a policy that forces you to do those things. The other one is your maximum password age, is the amount of days until you have to change your password. In this case, I have it at 90. The other one's 14 is the number of days until your password expires, and it'll issue you a warning. So once they hit that threshold, 14 in this case, it'll say, hey, your password expires in 14 days, so you want to change it now. And then the other field is in this case 30, the number of days of inactivity before the account is disabled. So if you don't log in 30 days in this example, your account's going to be locked. It's going to be disabled. Then the last field is the absolute date to disable the account. So think of it as you work in a company, you're a brand new employee, your contract's going to last only a year. They'll set that date on your account to the day that you're supposed to leave. So if you come back the following day because you forgot something, you're not able to log in at all. And if you somehow got extended, they need to go ahead and change that date so you're able to log in.